days. Morning. This will be second episode, I guess. Okay, chapter 1. FMF number 2. Section 1.1, getting started. a.out. When you're done, when you find with whichever program you're using to compile your program, whatever software you're using to write your code, the compiler will spit out a certain file. Once you're done, it'll save it as a file. It's going to come out as a C file. The C program is going to come out as a C file. It's going to be, and the example again, Hello World is kind of like that basic example for every software developer. The first program you learn is a Hello World, a variation of that Hello program, Hello World. When it's done, let's call it Hello because it's a Hello World program, right? Your program's going to spit out hello.c. That's the name of the file that you're going to save to your desktop or wherever you're saving your files to, your local drive, wherever you're saving it to, desktop or whatever it is in your case, it doesn't matter. It's going to be a hello.c file because that's the name. You named it hello and it's a .c because it's C language. From there, you're going to have to navigate. You're going to have to know how to navigate your command prompt. Pull up the command prompt, navigate to the location of this file, hello.c, and you're going to run that file in the command prompt. And the book does not go over this and how to do this. Command prompt is another thing you're going to want to have a good grasp of. COMM. And how to spell is another important tool when you're developing software. Command prompt. Learning how to navigate through the command prompt is going to be very important. Creating files through the command prompt, stuff like that. That's where you're going to create the C. There's a certain operation, I guess, or function you could type. Well, you got to type in cc space command or hello C. I forget exactly. Yeah, cc hello C. So when you go in your command prompt to cc hello C, and that'll spit out the a.out file, and that's going to be your program. This right here is your program. The a.out that can be renamed. You can name it to whatever you want, and this is depending on the system you're using. If you're using a Windows, what type of program files are downloaded for Windows? Executable files .exe. So you're gonna want to name it hello.exe. You're gonna change a.out to and it'll format it to be a Windows type program, or if it's a Mac .dmg, whatever you're using it. I don't know what you're using, but you can rename that program, and that becomes your file. The a.out file, that's your file. Section 1.0, that's the first part that they talk about. But it'll cut because of course if you want 1.9. There's 10 sections. One was, if it's a Windows, you're going to save an exe file. And that's about that for a.out. That's how you execute it. That's how you get it to someone else to use it. That's how you put a bow on it. A.out, done. Standard library. Standard library is this up here is a reference to the standard library. Okay, this needs to be on the beginning, at the very top of every single one of your programs. Standard library, because it's a reference for functions. Printf. The Hello World program that we developed, part of that program is printf, right? Printf. Let's capitalize that. Hello World. Okay, that's a comma. That's a comma, right? That's basically what it looks like, right? A Hello World program. Printf. I'm trying to show you this right here. Printf. That comes from the standard library. Okay, it's a place for your for the compiler. that translates your program that translates your C program, the language that you've written. It translates that language, a C language, which you've written. It translates that language into a language that the computer can understand. That's what the compiler does. It compiles your program, translates it for the computer. Hadouken. Yeah. I used to make those voices way better. Okay. Printf, standard library, and again, it's like kind of like the tool. It's kind of like a toolbox, kind of a toolbox. Printf is a tool that you're gonna use within that toolbox that's inside the standard library that you reference at the beginning of every single one of your programs. Okay. Printf is an example of what's found inside the standard library that we reference by using octothorpe, include, space, greater than, less than, stds, io.h, greater than. Boom. Standard library. That's it. If you want to do some more research on the standard library, I would highly suggest you do that, so you can see which other tools are available to you. Do some research on what the standard library is. You might be surprised at what you find. Standard library, done. Escape sequences. In our temperature converter, we have a temperature converter, right? Fahrenheit, Celsius. Okay? 0 degrees Celsius is negative 17.6 degrees Celsius. Okay? If we want to write a program that prints this conversion and all, so for 0, 20 degrees, 40 degrees, 60, if we want a program to print this for us when we click start, run, and we want to be able to see this conversion after we've typed it out, escape sequence is this right here. This is it's not that is accomplished by an escape sequence, an escape sequence N or T double quote backslash. This right here is a tab, right? That's all it is. Tab. That's what tab is. That's what escape. It's an escape sequence for tab. Slash T says tab over. So when I write my program, I'm gonna say 0 Fahrenheit is equal to 0. It's gonna be right here, right? And then I want, instead of printing out the conversion next to the 0, instead of having 0 then negative 17 degrees, because that would just look funky, because it's like 0 right next to it, negative 17, and then 20 right next to it is whatever, 14 degrees, and I don't know the conversion, 40, and then 28. It's gonna be right next to each other in the program. See, if you write your program, you'll see you'll come across things like this when you're writing it, when you're testing it, when you're debugging. You're gonna write your thing, you're gonna run the program, and it's gonna be printed out like this. Numbers right next to each other. 0 degrees, negative 117, 20 degrees, 48 degrees, whatever the fuck the conversion is gonna be right next to each other. Well, aesthetically, it doesn't look very pleasing. It's not what you want it to look like. You want it to look like an actual chart, right? With 2 columns. You want 2 columns? Yeah, you want 2 columns. How do we accomplish that? It's a simple thing. You just tab over. You got 0, tab. You just put it like in quotes, and then you're gonna complete the code with whatever your formula is. So it's gonna be 0. It's gonna be written down. It's gonna be you're gonna write it in your code. Here's an example of the fucking. We can do examples. It's just a tab. That's all that means. Tab. /n is a new line. So that is also something you can do within the temperature converter, or else it's just gonna keep it's gonna keep printing the numbers in a single row. But if you need to tell it after you've done this conversion in your program within the algorithm, you're going up by steps of 20, increments of 20, right? After every 20, within your formula, within your program that you've written, after every 20 degrees, do a /n. What that does is brings it to a new line. And then at that point, 0 will have been converted to -17. Okay? And then the next increment is 20. Let's do that equation for 20. At the end of that equation, another line. And then it'll now be 40 because of our equation, because of the temperature converter equation or whatever it is we're doing. It's a loop. It's a loop, right? We're writing a loop. We're going to do the same thing over and over again. After it completes, new line. We have a value for after we run our program. We got a new value. Put that new value out after a new line. It's now 60. Are you getting the gist of it? And then after the 60, we're going to do /t because I want a tab. I want the next conversion after we got our new value. We're going to do our math conversion. Or no, we're going to do a tab first, and then just do a tab after we get the new value. Do a tab, and then we'll pull our formula to what we want to do with this. I was right there with this number. That number. Tab, and after that tab, another line. I'm going to repeat this process till we get to our upper limit of 300. So, as long as we're less than or equal to 300, continue doing this formula. As long as x is less than or equal than 300, keep doing it in increments of 20. Keep doing it in increments of 20. In between, I want a tab, and then after, I want a new line. Boom, 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 boom. Escape sequences tighten that up. That needs to be tightened up. Finally, comments. This one's fun. Fucking comments. There's likely gonna be a time where your program might be looked at by others. Maybe team members within a team. You're working within a team to build a program. Maybe you've built a program for someone, right? And I don't know. You've done other programs and you forgot specifically what you did about that other program. They call you back and like, hey, can I make a change to this? Can you make a change to it? Like, I wanted to do this instead of that. Instead of increments of 5, I want to be increments of 4. Like, I don't know how you did that program, but can you change it? Fuck yeah, too easy. Not if you don't like comments. I mean, comments are going to be a lot easier for you personally. And if you're within a team, it's going to be easier for them to understand what your program is doing and what you did for the program. Comments are very, 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 very important. Again, proper etiquette, stuff like that. Use as much comments as often. Use comments as often as you save your file. How about that? When you're doing, how about them apples? How about them apples? Like apples? As often as you save your program, you should be writing comments. Comments are initiated by / asterisk is the initiation of a comment. Everything within the asterisk or after preceding the asterisk and that has no relevance to the program. C that's invisible as far as the program is concerned. So as far as C programming is concerned, everything within the comments indicators is invisible to the program. But write comments. They're important to everyone. And that's gonna round off chapter 1. Or section 1.1. White spaces are ignored. Comments are very important. And consistency is key. And with that